Well, gentlemen, we're here today to talk about an older M4 or see what do we got on the front of this thing? This would be like an old M4B or M-800. But it has been modified by somebody that kind of knows what they were doing. We got a bunch of 5 waters in here, as we can see. That's not stock. And as we can see here, the power wire has obviously been upgraded. The problem with this is the way the power wire has been upgraded. By the time the current gets down here, it's way less than it is here. And by the time it wraps all the way around over here to drive the 2-pil section, we have a lot of loss. The other thing is this output tuning capacitor is way too small, woefully inadequate. You're going to have some problems there. A lot of the solder work in here is iffy at best. We don't have any of our 10 or 11 ohm resistors popped, but what we do have is like this poor feller here. This poor guy here is fried. The final one is still good, but this one here is a little discolored. So usually what causes that is one of these caps has gone bad, or this cap has failed in the past and they didn't bother to replace these resistors. So what we've got to do first is hook it up and see what's working and what's not. And then we're going to come through and we're going to modify this. My friend that owns this is going to run this with a Cobra 29. It's about 30 watts peak envelope power. It's 2 MRF 455s punching into 8 2879 Toshibas with the variable attached. Some of you guys are going to call foul and say this isn't stock. And I believe that this one is not stock, since it is low, medium, and high, which on the ones where the knob is a variable like this, which some of the older ones are, which initially made me think that this was an older one, it says variable. This doesn't mean a lot to me. As long as this is done properly, it doesn't really matter. As we all know, the RF comes in through here, runs through this piece of coax, runs around, goes through, and then back around, and it comes here. Now there is an attenuator that went from here to here, which hid the input tune circuitry, which was always never right on these boxes. It hid behind that attenuator. Well, that attenuator also allowed it to not be overdriven and was part of this circuit to help it not be so out of whack. The low, medium, and high, that is. Which inevitably, I cannot tell you how many of these I have seen over the last decade and a half of working on these, where the low, medium, and high is completely messed up. These guys are just suckers for being overdriven. They just get beat to the ground, and it is part of the game when working on messengers. I'm just grateful that this one has at least got a fan on it. Okay. Things that do make me be concerned is that this board is kicked that direction, which is forward, and this board is kicked back. This is the relay that drives the bias circuit. Here is our load resistor, or load diode, and then the other one's over here. These are our load resistors, which these are 22 ohm. Most of us in the amp business, we like to use 10, but we'll use a little bit heavier wattage one. This is the bias circuit, this direction here for the driver section. This is the bias circuit for the final section. This is the exact same circuit that we all use, by the way. X-Force, you know, some of the older Dave made stuff, I use it. Everybody uses the same exact circuit. Some guys will get really fancy and they'll use a voltage regulator, and there's some pros and there's some cons to that. I think the cons outweigh the pros, in my opinion. Other people's opinions differ, though, wildly from mine. The reason the diode is buried down here on the heatsink is as the heatsink heats up, there's thermal paste around the diode. That thermal paste transfers the heat to the diode, and it changes how the diode reacts with the circuit. So therefore, we get a voltage change in our biasing circuit. So he says just upgrade what needs to be upgraded. The ground wire here in the back, which is very shittily soldered down here in this back corner, we're going to pull this the wires out completely and start over, but that's a no-fly, no good. I like to hark back to the old messenger days. There's some parts of the circuit that I admired, and then there's parts of the circuit which I never cared for. The phenolic, they would use paper-thin phenolic board that went across the top of all the transistors. We found all that does is hold heat, plus all the lead and tin, the solder that's on top, holds heat on the top of the transistor, which is not what we want. But the way that they brought the ground in, it made the bus distribute from the center out, was more efficient than this. This ground here is working on the principle that the case is going to carry more ground. Well, the heatsink will carry way more current by far than the board ever could. It's sheer metal mass, right? So is this pounded out 70 billionths of a thousandths thick copper going to be able to carry more current than this giant hunk of aluminum? Never on any Sunday, not even on a good Tuesday, is that going to happen. The heatsink will always carry more current. The downside is there are no screws anywhere in here that are carrying ground from the heatsink to the copper clad. So the ground here has to work its way through all these different traces and through all this different board, and then goes up in between each one of these circuits. So the wire that is here in the middle is what's carrying all the ground in the middle of the transistors, and it's not even soldered in all the way. So what we're going to do is we're going to pluck out all these five. Well, first we're going to test it and see what works. Then we're going to come back, we're going to pluck out all these 5 waters, and we're going to do some ground wire upgrades in here. We're going to clean up all this solder work, and then we're going to give it a bath. This is a neat looking box. I cannot wait to see what we got going on for an input tune, and I cannot wait to see what happens over here with the output circuitry. We have to replace this resistor at some point, assuming that none of these transistors are bad. Usually they are not. Usually what happens is one of these caps go bad, and if a guy's got a set of watt meters, he'll see that one of these caps will devaluate. It'll go out of value, out of spec, out of tolerance, and then there's an imbalance that forms, and the power will drop off. It'll go, it'll fall off by a couple hundred watts, and then we'll smell something burning. That's if a guy's got a set of meters. If he doesn't have a set of meters, he's going to keep running it until all of a sudden nobody's hearing him anymore. And that's when we pop all the pills. I don't see any blown 10 ohm resistors down there. So it leads me to the conclusion that maybe the transistors are all right. Maybe. But let's find out for sure. Okay, so this is what I was talking about. We are gonna, let me dance around the tripod a little bit here for you real quick. Plug in the FLIR, since it's insisting it wants to die. So let's go ahead, let's run this for a second. Got the variable all the way open. We're putting a whopping, hold on to your pantyhose for this, 18 watts in this amp. So we'll go ahead, we'll run it. Making a whopping 600. Okay, we don't want to run this too long. Let's back the camera up. And we can see right off the hop here on the FLIR. I know it's a little blurry, but right here is where our combiner resistor is hot, and so is that one. So we're going to take a look. This cap here is very hot. This one here is also very hot. This one is cold. we get down in here, we'll take a high-res photo for you guys, and then we'll do another high-res photo for you guys. So that tells me that this cap and this cap have fallen out of their value. They're 1,000 puff a piece, no big deal. Now let's look at this little tiny trimmer cap. It is also getting silly hot and falling out of capacitance value. This one over here in a corner. Of course, everything here is failing me, so let's try this again. Okay. Take yet another photo. I don't want to run it any more than that because I don't see those transistors are turning on. Those are turning on. Those are turning on. Yeah, 10 ohmers are getting hotter than hell. Those seem low to me. These two transistors, something seems to be going on. So these two seem really cool compared. I mean, these are like in the 80s and these are in the hundreds. So we might actually have some pop pills. But I'm going to lean towards the fact that we don't at the moment, and we're going to check the value of our output tuning capacitors in this one here. But for us really to go any further, this needs to get changed. I have to bring you in on this beautiful solder joint. I got to show this guy to you guys. We're not going to mention that that output inductor coil is the wrong size and it's got the wrong number of turns on it. But I want you guys to see the beauty of this solder work that's here on this joint. It's just breathtaking. Wow. Look at that. That's wow. Oh man, that's why I said we got to replace some of this stuff, because it's the positive lead was not too far behind it. It was down here, and it was just held on with a pubic hair worth of solder. So have faith. Like I said many a time, this is not my first one. She's not my first girl. We're going to do it upright. Bad. Okay. Okay, so now we're going to check our output swamping capacitance on each one of the output transformers. These should all read 1,000 or roughly in that department. These are 5% variant capacitors. So that means they can have a window. So it can be from, like, if it's 5%, we'll say from 995 picofarad to like 1,010, 1,005, something like that, picofarad. So the Tell No Lies machine here, we'll hook this up. Jeez almighty. You can tell I've been in here working with fiberglass the last couple days. Everything's got a nice thin layer of dust on it. Okay, so this machine is telling us that there's 1,005.6 picofarads worth of capacitance on this one cap. Remember I said these two transistors are really cold? Let's see what this shows us. $53.1. Son of a diddly fart. All right. Let's hook this up here. 1009, 1008.8, and we'll hook this up here. 1005.8. So what did we just learn from this? That this one capacitor is so low that it throws off the whole tune of the whole circuit for this 2-pill section. So those of you guys that are new to the channel, even though my analytics tell me that 90% of you guys are return viewers, for some reason YouTube will not push this channel. I don't know why. That's why I say subscribing is so important. How this works is this is an amplifier, this is an amplifier, this is an amplifier, that's an amplifier, and that's an amplifier. So it's 4 final amps, 1 driver amp. Total of 5 amplifiers inside this one case to make up a amplifier. If any one of the parts falls out of tolerance too far with any of the other parts inside this box, we have an imbalance. Hence we have resistors that get hot and burn up because they're trying to absorb the differentiating current or voltages or output potential of each one of the circuits. That's the reason why that this resistor is burning up. Now in turn, we're going to also check all of our input capacitors and make sure they're all within, you know, most common manufacturers with a 5% tolerance. Me personally, when I go to build a box, I try to have all my parts within a 1% tolerance. That means hours of sitting and measuring parts. You don't know how many hours I've spent with a pile of capacitors sitting here in 4 different bins with all different labels on them, and I'm sitting there measuring and putting parts in different bins. So they're all within a 1% tolerance of each other. Is it really important that this is a 1,000 puff on the nose? No. Is it more important that we have 1,000, like 1,005, 1,005, 1,005, 1,005? Yes. Versus 980, 1,010, 990. You see that little bit of capacitance variance will affect the whole circuit overall. That's why I try to stay away from building anything bigger than a 32. It's a pain in the ass to build like a 48 or like a 64 or anything bigger than that. I mean, that's 32 2-pills in a 64 pill. So that means you have to get every single part, all 32 2-pills, within like a 2% or 3% tolerance of each other. So when you go to run the box, you don't have an imbalance. And then once the amplifier is running, you have to go, how long are all those parts going to stay within tolerance? Did I build them at such a standard that they're going to stay together? Okay. Let's go check these caps. I want to look at what's going on here. And I want to look at this cap. This cap has got, there's the most electrical pressure. And I like to think of it as pressure, even though that's not the correct clinical term or the technical correct term. The most amount of current that you're going to have present and voltage present is going to be here and here on these 2 caps. Why would we want to use such small capacitors? Even Arcos that they were designed to originally have in here, which sit from here to here on the board, have a higher kV or kilovolt rating than this 500 puff electrolytic, which we can physically see is discolored and blackened. This cap right here. So, if anything, this cap's got to get changed, this one's got to get changed, and I want to put the right size inductor in here. This is something out of a Palomar or some bullshit. I just went to go check these caps, and it dawns on me that these are 330s, and in the stock amplifier they should be 1200. And so then my brain went, let's look at the wraps and the transformers. As we can see, we've got 2 wraps showing on the front, 3 on the front, or pardon me, 2 wraps on the back, 3 on the front. Somebody has gone over and tried to convert this into a Dave Made style amplifier. Weekend warrior is all I'm going to say. Go Joe. Okay. Well, it's not so bad as long as you compensate with the right value of capacitance here. And then we have to adjust our capacitance here as well. So it's just been modified. This is not anywhere near stock, and it shows. The other thing I want to cover is I get a little leery when these boards start to get tilted. The little foil traces that make up the contacts at the bottom of the relay board, if they get bent, the solder joints get really weak and they have a tendency to crack really easy. These boards have been off and somebody has resoldered them in their place, and they're actually on there fairly stout. But yeah, I think what I'm gonna do is I'm gonna pull all these caps off, obviously, because this is no good. I'm gonna pull all these 100 ohmers out because that's no good for right now. It's because I got to have access to all the solder joints. And then I got to go through and I got to reflow all these joints in here. Take this inductor out, take these 2 caps out, and measure them just for shits and grins. And then I got to wash this thing because it's filthy. And then we'll move on. Okay. We have done about 90% of the things that we wanted to do in here. Replaced all of these with metal clads. We got rid of, don't know when they're going to fail you, but definitely going to let you down capacitors. Replaced these in metal clads. We washed it. De-solder flicked it because there's quite a bit of that. Did the power wire distribution upgrade. And the whole idea is to add more surface area here. So we'll bring our 4 gauge in. We'll sneak it from here directly by this combiner, and we'll tie it right to this board. We're going to bring our ground in. We're going to tie it into this eyelet here that we've created in the center of the amp. We also added an auxiliary ground to go to the middle of the 2-pil driver section. Upgraded the positive rail with Teflon wire going for the 2-pil driver section. Put the proper size inductor in the output network. Went ahead and upgraded to a metal clad capacitor and another metal clad here. The only thing left I got to check is to make sure that this inductor isn't too far out of whack for this circuit. Got to put the flybacks in it, but we're about ready to where we can play with it. So I'm going to put all the flybacks back in it after we've done our ground upgrade. Remember, we had that soldered down over here with the world's shittiest solder connection was over here in the corner. So I'm going to redirect it and bring it over here. Get the ground down to the transistors as best we can. Somebody else has already come along and reinforced all of these traces, which I think is a great idea. Checked all of these caps. Everything's in spec. So now that we've replaced this cap that was at 50 puff, woo, 50 puff instead of 1,000, pretty sure that'll eliminate our imbalance issue. We upgraded all of these to 5-watt resistors here across the output section. A little bit of an overkill. As long as everything's in balance, it doesn't really matter. What it does come and do is help when there is an imbalance. So we got rid of this, which the longer you look at this, the worse it gets. This is actually a bunch of pieces of resistor wire that's all been kind of very carefully tacked together and soldered into one piece. Got rid of this fugly little inductor, which was the wrong length. Basically got rid of all the little weak links in the chain here. And so let's put the flybacks in it, and let's put the power wire in it, and play with it. Okay. So now I got my inductor, my power wire system in it. I had to change the driver section around quite a little bit. Had to change the inductor here quite a little bit, and we'll get to all that. These capacitors quite a little bit. Basically, all of these parts. Now remember, when we started out, the max I could get at the dead key was 200 watts, and it was barely making 6, right? So I fixed the bad cap, and it came up to about 700 and some change, but the driver section was a mess. I don't know what the logic was of taking this inductor out and replacing it with this short little jumper. I mean, it looked okay over here on the watt meter, but when we looked at it on the spectrum analyzer, it was really quite scary. That's not the greatest thing in the world, but it's way better than what it was. What we seen going on here was like the Sherwood Forest over here on the spectrum analyzer, so that's not too bad. Our secondary harmonic is at negative 41 dBm, so we're gonna let that fly. Here's the difference. We're on the same voltage, by the way, 12. So now we're dead key in 3. Hello. We forward modulate, we're going to 8 easily, and that's on 12 volts. Now, I talked to the customer, and he said the best he could ever get out of this was 600 and some watts. And I was like, oh, shit, really? Yeah, 600 watts. So let's go ahead, we'll turn our voltage up a little bit. And we'll come on up here to 15.1. 1000 watt slug in peak, by the way, 1000 in average, 5 watt slug in reverse. And we're only putting about 25-30 watts in it. It's our pass-through reflect. 1212. Very negligible. 1212. All right. And this, by the way, we're putting into it I think about 1.5, almost 2 watts worth of carrier. I'll back this down so it's at 1 watt. Get a whole lot of swing out of it that way. So we'll turn on the 2x8 here. Off the scale. Nearly 500 bird. And that's out of the bench radio that doesn't do a whole lot of power watts. Like, you know, a lot of bird. We're on the 1000 watts, now we're on 2000 watts, so the needle fully deflected is 2000. That's 1000, 12, and 14. 1380, almost 1400 watts, my way. And it's clean, like way clean. I can suppress these other 2 harmonics that are here by changing this trimmer here. But when I do that, I cost myself almost 400 watts. And they're so far down, it's not going to bother anybody. So, 1 2 1 2 1 2. So my friend, just keep your dead key down around a watt or so. 1 2 1 2. This thing is going to perform way better for you than what it did before. Turn the amp up on the side so its fan actually does its job. Otherwise it's going to get really hot. This thing was a mess. 600 watts max. Doubled its power. It's clean. It's not producing any harmonics. I'll take it and smile. You know, I did one of these one time where I hot rodded the shit out of this thing. I think I did it for my friend Greg Marco. The best I could get out of one of these was like 1900 watts at the time. I'm sure if I went back and revisited that, I could probably get more performance out of it. The problem is the heatsink is too small and there's not enough airflow. Not for 10 transistors. It's just not. I got a 4x16 that I built on a 16 pill flat, which is just a little bit bigger than this. It was 2 driving 16. I took it all apart, put a new board on it, turned it into a 4 driving 16. I ran that in my truck for a long time. It made 4,000 plus watts, like real consistently, like all the time. It just wasn't enough heatsink, even though I had 4 fans on it. Ooh, I mean, hauling ass, screaming balls all day long. Just, it still wasn't enough. So that's when I decided I'd build myself that 48 pill, and now I just drive it with a 4 pill, and I get 6,000-7,000 watts out of it, and I'm good enough, good to go. Well, my man, you're done. I'm gonna put the lid on it, and now I'm off to go see the plastics guy. The plastics guy has got to order me up some plexi, and I've got to build this guy an enclosure, like what I did for those LTO batteries. It's like in my truck, and the same thing I made for Bullet. So, yay! Off I go. I'm off to the plastics guys. So we'll continue this on here in just a hot minute. But the rest of my day, since this is done, I'm going to go play with a project that I'm working on with all my Patreon people. And it's a Patreon exclusive thing. All the test data, we're working through a little test project with the guys on Patreon. And what I mean by that is I'm building something over here. I told them what my goals were, what my plan was, where I wanted to head, and how I was going to go about getting it. And I talked to them all the way through it, and I'm taking all their input on it. There's a lot of cool shit going on the Patreon channel. If you have the opportunity and you've ever learned anything from me and you want to try and help support me in any way, or show thanks in some way, just come over and join the Patreon group. It's like $1 a month. There's a ton of cool shit. That, and you get exclusive access to me. Anything that any questions, anything, it doesn't matter what it is. I'm all over it. It's, I don't know. It seems like we're having a lot of fun with it, and the guys on Patreon are really enjoying it. So for now, this is done. I'm going to put the tin on it, put a sticker on it, get it ready to come home. But now I got to go to the plastics guy and go order up some stuff. I'll be back. It's the end of a very long day. And plastics guy calls me and says, "Hey, your shit's ready to come get it." I'm like, "Okay, I'm on my way." So here I am at the end of my day. We're going to use a little E6000, which, if you guys aren't familiar with E6000, you should be. It's the best glue in the world. It's crystal clear, transparent, level 6 Senelic, basically. Shit, I forgot to prep this one piece. Anywho, this is for an LTO battery case for the same guy with the Messenger. Which, why am I saying that? You guys know that. That's where we just left off at. I'm telling you, long day. And inflation is a real thing, by the way. When I built my case for my truck, the polycarbonate, otherwise known as Lexan, was cheap. Oh, this is gonna suck. This first joint always sucks. It was cheap in comparison to this. It was like 80 bucks. So then I built the one for Bob, right? And that one was like 150-ish bucks. Not even a couple months later. It's squirming. Come here. The polycarbonate here that you see on the table was around 200. Believe it or not. Expensive. This shit's just going to keep getting more expensive, I'm telling you. So this is the base. And then we'll glue on 1, 2, 3, and the 4 sides. And then this is the lid. And then the dual bank of LTO batteries drops right in here. And then he can go and grab himself off of Amazon 2-part Craft Smart epoxy. It's like 30 or 40 bucks for a gallon of it. 1 gallon is all you need. You are going to mix thoroughly, and listen to these instructions. Mix thoroughly for 5 minutes. And I don't mean, oh, okay, good enough. Been 5 minutes, good enough, drop batteries in. And then come back to me in a day and be like, why isn't this stuff hard yet? It's running like pee. Yeah, it's because you did not mix it thoroughly. I will take a coat hanger and bend it over a piece of welding rod, bend it over, and make it so it's got a really narrow hoop to it. I'll put it in the drill and slowly turn the drill. You don't want to turn it too fast because then you're going to knock a bunch of air into the epoxy. And it's going to look like it's snowing inside the epoxy after you put the battery in. Just and beat it for at least, they say at least 5 minutes, I'd say at least 7 to 10. And that's at 70-degree room temperature. And then very slowly insert your battery down in the case, make sure it's square, and then leave it alone for at least 2 days. Even though it'll be semi-hard, so many dirty jokes can be made right now, I'm here to tell you. It'll be it'll be not workable anymore after about maybe an hour. But you don't want rapid clear epoxy because that stuff gets too hot and it'll end up damaging the cells. But this is the coolest way and the most impact resistant way that I could think of. Cool. The cool factor is the most important thing. But if you haven't bought any of this stuff yet, you might want to think about it. This is E6000. It's the same thing that we can use to glue down the lids of transistors with if they pop off. Even though I strongly suggest you don't do it because it takes a very steady hand and a couple special tools to apply it to the transistor, and you got to know where to put it and not put it, otherwise it'll end up getting in the leads of the transistor and fuck the transistor up. But this is commercial grade Synelic glue versus, you know, your wannabe Synelic glues. This is technically Synelic, but it's way watered down. This is what they consider to be an industrial strength style of Synelic. So, and they make all kinds of Synelic, even Synelic that's based with rubber. So. Okay, I'll be back when it's time to put on the other piece. Well, we made ourselves a box. We made it with the E6000 glue, and I'm not gonna lie, I even used the Cinellic. As much as I didn't want to, I didn't feel like I could trust that E6000 to hold a good seal. So all the joints have been gone back and re-glued with Cinellic. I did that for a couple reasons. One of the main reasons is I don't want the epoxy to leak. And two, this has got to go on an airplane ride to the other side of the known universe, known world. So this thing's got to stay in one piece. It's not like it's gonna stay around here locally and I'm gonna be able to twiddly fart with it if the case cracks. So we've gone in here and bead sealed all the edges on the inside with epoxy, or not with epoxy, but Cinellic, and then put quick set hardener on top of that. So I feel fairly confident that every joint in here is going to be tight and is going to keep the epoxy in. But we have one clear $200+ impact resistant case. the cost of acrylic has gone up so much. It is shocking. Like I said, my first case is a little over $100, and this ain't that. This is $180 in just material for this case. At the time of the filming of this video, as everybody likes to say on YouTube nowadays, at the time of the filming of this video. So, guys, I'm going to jump onto another project. I want to thank you all for tuning in and watching this messenger rebuild, this acrylic case build. Just one less thing I've got to think about over here, and one more project done that's going to allow me to move closer towards taking on work in September, if not a little bit earlier. The way things are looking now, so where we're at, July, I might be thinking about taking on work in the end of August. We'll see. I'm getting close. I'm getting really close. I'm really excited. Oh boy. Some of the projects that have been called and been offered, I cannot wait to start on. So, gentlemen, my name is BBI. Big thanks to Siglant, XS, Bird, Coaxial Dynamics, MechMan. Big thanks to all of my Patreon supporters and my fellow Patreon brethrens. And a big thanks to all of you. Gentlemen, I'll see you. Thank you. And click, click, click.